Hello, class. I got a document cam, and I think I got this thing to work. So I'm gonna put some notes for chapter 2 on a video here. So just bear with me. I'm gonna go ahead and get started. Okay. So we'll begin with chapter 2, 2.1. This is your distance and midpoint. Your distance and midpoint formulas. When you take a coordinate system, the x and y plane, each point on the graph has an x value and has a y value. Sorry, an x and a y value, excuse me, the coordinate. So if we have this second point be x2, y2, and this first point be x1, y1, there is the middle point, which is called the midpoint. There is the distance from one point to the other, labeled as a lowercase d, which is called the distance. So we're looking at two things. So between these 2 points, x1, y1, and x2, y2. The distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. The midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. So these are the two formulas for the distance and for the midpoint. You can use these as you take the homework, as you do the quizzes, as you do the test. It's okay with me that you use these formulas. What I'm gonna do is real simply here. I'm gonna write up a couple of examples and just walk you through it. So examples. Find the distance and find the midpoint. I'm just gonna get 2 points at random. Let's say -2, 3, and let's say 4, -5. Doesn't matter which point you choose to be your x1, y1, and which point you choose to be x2, y2. I typically go left to right. So if the first point represents x1, y1, your second point represents x2, y2. The midpoint formula says x1 plus x2, -2 plus 4 over 2, then y1 plus y2, which is 3 plus -5 over 2. This becomes on top here -2. This on top becomes -2. So the midpoint is -2 over 2, comma -2 over 2, which simplifies to -1, comma -1. So the midpoint is the point exactly between these two given points. Essentially what it's saying. Now your distance, following the distance formula up here, parentheses inside of a square root, second x minus the first x, 4 minus -2, all squared, plus second y minus the first y, -5 minus 3 as we have it labeled here. These two negatives become plus, so 4 plus 2 is 6, 6 squared. -5 minus 3 is -8. -8 now squared. 3 squared is 6 squared is 36. 8 squared, -8 squared is 64. So when you combine it, that is 100. So the distance would be the square root of 100, which simplifies to 10. That is your distance. And this is your midpoint. Essentially, that's all it is. It's essentially a short section. Just want you to go through the formulas. So I'll do one more just for completion here. So let's say 6, -8, and I don't know. Let's say 4, -4. And then it doesn't really matter here, just for practice. So first point is x1, y1. Second point is x2, y2. So the midpoint, first x6, x1, plus second x2, which is 4, divided by 2. Then y1 plus y2, which is -8, plus -4/2. 6 plus 4 is 10. -8 plus -4 is -12. 10 divided by 2 is 5. -12 divided by 2 is -6. So 5, -6 is the point right in the middle of these two given points. And now your distance, second x2 minus x1, so it's 4 minus 6 all squared, plus second y minus the first y, -4 minus -8 all squared. -4 minus 6 is -2. These two negatives make a plus, so -4 plus 8 is +4. -2 squared is 4. 4 squared is 16. 4 plus 16 is 20. So this becomes a square root of 20. Now in chapter 1, we simplified square roots. Now in square roots, essentially, even though it's not perfect, it could be broken apart into one factor that is perfect, greater than 1. So 4 times 5 is 20. 4 divides 25 times, the square root of 4 being 2. So this is 2 square root of 5 simplified. And that is your distance formula, or your distance. And essentially here is your midpoint. So just something like that, just running formulas. You have your distance and your midpoint, and then just run the two formulas in whatever order you want. And I believe that is how it has the information on your my math lab. So hopefully this will help with 2.1. I'm going to turn the page. And now essentially 2.2. Just want to give you a little preview of each, just walk you through it, just give you a couple of examples, and I'll explain to you how this works. So circle, to the best of your ability, is a point in the middle and the set of all the points that are equally distant from that point, equally distant. So this point is known as your center point. The distance from the center out to any point is your radius. And any point on the circle is called a solution point, or a point on the circle. Essentially you have center, a radius, and a solution point. That's the terminology here. Now there's also diameter. The diameter would be the distance from one point on a circle to another passing through the center. Essentially that's your diameter, but it's not a huge issue here now. It's not super important that we know that for this lesson. So let's see here. Let me give you a general idea of how this works. On an XY coordinate system, the point in the center is typically called or labeled as HK. So this point on the circle is known as HK. The distance from the center out to any point known as the radius is labeled as R. And the solution point we name as XY. And so what they do is they use the Pythagorean theorem to kind of come up with this idea of the equation of a circle. So there is the center radius form of a circle, which again sometimes I call standard form. There's many ways of calling something standard, but ultimately the book I think uses center radius. So formula is based on the Pythagorean theorem. If you made a little right triangle out of this, you'd have a squared plus b squared equals c squared. So you'd have this formula. Where essentially your center is hk and the radius is r. So essentially that's why they call it the center radius form, because you need a center and a radius. So a couple of examples. Just want to show you here, like if you have x minus 1 squared plus y plus 3 squared equals 16. The formula is minus for h and minus for k. So these two values that go in the formula are opposite signs. So here we take this value, positive 1, and notice it's a plus 3, we take negative 3. So it's the opposite sign, opposite signs. The radius comes from this side of the formula. That's r squared. So r is 4. Again, solving for r by square rooting both sides to get your radius to be 4. That's all it is. Just one more example here. It's not so bad. X squared plus y plus 4 squared equals to 25. Now this x has no parentheses, so in here we take the point 0. The y we take the opposite sign, 0, negative 4. So if there's parentheses, we take the opposite signs of numbers. If there is no parentheses, we take it as 0. And then r squared is 25. So r would be the square root of 25, which is just 5. Okay? Now, if you're asked to kind of graph the circle, and I try to make these examples really easy for you on the math lab homework and the quizzes. So let's say x plus 1 squared plus y minus 2 squared equals to 4. So in essence, get the center, opposite, opposite. Your r squared is 4, so your r is 2. So when you're drawing something, when you're graphing, this means that from this point, you're going to go equally in all different directions, 2 units. The easiest 4 unit or directions are up, down, left, right. Give me 1 second. Okay, so as I was saying here, I'm going to go to the point -1, +2, which roughly puts me here. I'll label the coordinates in a moment. From here now, this being 2, I'm going to go up 2 units to 4. And then I'm going to go down 2 units to 0. So I know mine's a lot really to scale perfectly, but the idea is up 2 spaces, down 2 spaces. Then I'm going to go from the same center point, left 2, should put me at -3. And then right 2, which should put me at 1. So to the best of my ability, even though this is not perfect to scale, I'm going to connect the dots to the best of my ability here and make a circle out of it. So more or less, that is your circle. Real simple, real straightforward. Hopefully it's not so bad. I'll do one more example. Let's say x minus 3 squared plus y plus 1 squared equals to 9. Opposite of -3, which is +3, opposite of the +1, which is -1. So there's your center at 3, -1. Your radius, r squared, is 9, so r is 3. So let's see if I can kind of graph this for you here a little bit. I'm going to go to the point 3, negative 1, roughly. That's not the scale, just giving you an idea here. This is the point 3, negative 1. So in the radius, I'm going to go up, down, right, and left. It doesn't matter what direction you go first. So I go right. Excuse me. I go left. Right 3, left 3. Then the negative 1 is the y value. We're going to go up, down 3 units, if I may here. Down 1, 2, 3. Puts me down at negative 4, roughly. Then I'm going to go up 3 units. Puts me essentially at positive 2. So it's not exactly essentially perfect, but more or less. Mine looks like a little egg maybe, but it's supposed to be from this point, right 3, left 3, down 3, and up 3. So that's how you essentially handle 2.2. There's more to it, but I just want to give you the gist of it so you can be able to attack the quizzes and the homework, and hopefully the test as well. And you'll be able to use this formula, so hopefully it won't be so bad. Let's take a little jump into 2.3 here. And get my spiral fixed already. So 2.3, the idea of a function. I'll move my hand. I don't know if you can see it. Move my hand momentarily. I'm just going to write this out. A function is a rule that assigns exactly one output for each and every input. The input is x. The output is typically y. So, in other words, for example, there is exactly one y for each x. No more, no less. So as long as you have the rule where you have x and y values together, every single x value, instead of all the x's, each of them have essentially a corresponding y. The domain would be the set of all inputs, or the set of all x's. And your range would be the set of all outputs, y. I'm going to do a few examples, just kind of walk you through here. Just going to show you what it would be to be a function, not to be a function. So let's say something like this. The top row would be the x set of x's, negative 3, 2, 6, 8, and 4. And the y's would be 5, 4, 1, 5, and 1. Notice here, every x goes to a y. So negative 3 goes to 5, 2 goes to 4, 6 goes to 1, 8 goes to 5, and 4 goes to 1. Every x has a y. Every single x has exactly one y, so this would be a function. That's what it means to be a function. The domain would be in set notation, braces, all of the x's that you see. -3, 2, 6, 8, and 4. If any of them repeat, we only write them once. So in the range, all the y's, 5, 4, 1, 5, and 1. Now, while there are 5 outputs, there are really only 3 distinct ones because 2 repeat. So we only write the distinct outputs. So 5, 4, and 1. You don't write repeats more than once. So let's try a second one here. So we have x and y values. Essentially, every x still goes to a y, as you can see, but in the first column, 4 goes to 0, and in the fourth column, or in the fourth column of numbers, 4 goes to 5. So 4 has 2 outputs. 4 cheats, essentially. 4 can't have more than one output. It can only have exactly one. So this would be not a function. Now, I don't really like to put domain and range if it's not a function, but I believe that my math lab is asking you to put the domain and range anyway. So your domain would be 4, -3, 2, and -1. You don't put the repeats more than once. And the range, 0, 9, 6, 5, and 7. So essentially, every x has to have a partner, and no x can cheat. That's essentially what it means to be a function. So 3. Let's do something like this. Let's put the set in a circle. So inputs, and we'll call the second circle outputs. So let's say A goes to F, B goes to H, D goes to G. So all these inputs must have exactly one output. Notice that C has no output. So this thing is not a function. So every input has to have one output. There is exactly one y for each x. No more, no less. So every x has to have a y, and no x can have more than one y. So while I wouldn't ask for domain here, if it's not a function, I think your computer does. So the domain is A, B, and D, because C has no output. And the range would be F, G, and H. One more here. Let's use the same letters. This is left would be your outputs. Excuse me. Left would be your input. Your output would be the right. So let's say A goes to G. Let's say B goes to G. Let's say C goes to G. And let's say D goes to G. In this case, every single letter has a partner. I'm sorry, every single letter on the left has a partner on the right. So this thing would be a function. A, B, C, and D, they each have an output. Now, even though it's the same output, no letter on the left side has more than one output. So it's a function. Your domain, A, B, C, D, and your range is just G. So notice something about the function here. The Y value can cheat, and the Y value does not necessarily have to have a partner. But the X value must have a partner, cannot be left alone, and cannot have more than one partner at a time. That's what it means to be a function and not to be a function. Okay, let me turn the page. Let's continue this. Let's talk about from a graph. From a graph, you have what's called a vertical line test. And let's see, that was example 4. So we'll call this example 5. So let's say you have a graph. Let's say something like this. Let's say you have another graph. Something like this. Let's say another graph. Something like this. Fourth graph. To look something like this. And then a fifth graph. Let's say something like this. And let me throw in number 10. Let me throw one up here. I'm going to throw in 6 quick examples because this is short. So, vertical line test says you can run any vertical line you want through the function. Doesn't matter. If every graph is hit one time by each vertical line you put, we call this thing a function. So number 5 is a function. In the domain, this thing goes down into the left forever, right forever. I'm going to abbreviate D as domain, negative infinity all the way to positive infinity, left to right. The domain is how low you can go to how high, so the range is also negative infinity to infinity. Okay. Number 6, notice that when you run vertical lines, so you really just found one. If you find one that hits the graph at more than one point, you can find more, but if you find one, this thing is not a function. So you're cheating. Now, if it's not a function, I'm not going to, on a graph, I'm not going to get you worried too much about domain and range. But if you wanted to, if you were curious, the domain would be negative infinity up to 3. All left forever, all the way to 3. And the range would be down forever, up forever, negative infinity to infinity. I'll put it in there. It's not necessary, only if it's a function for me. Again, the third one. Every vertical line I run through this. Can you convince yourself? It's the graph only once. So this would be a function. Number 10. The domain would be what we call all real numbers, negative infinity to infinity. The range would be also all real numbers, negative infinity to infinity. Down, up. Number 7, it's a function, because each time you only hit the graph 1 point. That's all it is. So function, yes. And then your domain, from left to right, what we call all real numbers again, and the range, all real numbers again. 8, again, function, because every vertical line hits the graph only once. So we call this a function. The domain, again, the leftmost picture, the farthest this thing goes left on the x-axis, is positive 1. So we put a bracket to show that it actually touches positive 1 vertically here, all the way to infinity on the right. Now the range, the lowest y value that this thing hits is 2, and it increases forever. So we say 2 to infinity. And that is your range. Now this bad boy, he cheats all over the place. Doesn't matter. Actually, this particular one has 3 points that it passes through. So it's like saying that this particular input has 3 different outputs. So it's all kinds of cheating, all kinds of wrong. Not a function. And if you're wondering, just in case, the domain negative infinity to infinity, the range negative infinity to infinity. Goes forever down to the left, forever up and to the right. So all the way down forever, all the way up forever. So all real numbers on both sides of the picture. So this is from a graph. And now one last thing is essentially the notation. We call f of x. Function of x. And what we call evaluating. Easier way to think of it is kind of plugging in for x, so to speak. A couple of examples here. I'm going to probably just do one example. Let's just say example. This will be example number 11. So f of x, let's say, is, I don't know, x squared plus 3x minus 4. Let's say you want to find the following. Let's say f of negative 1. So this means x is negative 1. That is your input. So it means wherever x is defined in an equation, again, as an equation, so to speak, you put the input negative 1 in for x. So it's like plugging in negative 1 for x. So negative 1 all squared plus 3 times negative 1 minus 4. Negative 1 squared is positive 1. 3 times negative 1 is negative 3, then minus 4. From left to right, 1 minus 3 is negative 4. Negative 4 minus 4 is negative 8. This is your output. So some people would put this in a coordinate and say when x is negative 1, y is negative 8. Essentially how they look at it. But we're looking just for the output. Just to give you another example or two here, let's say f of 2. Again, same deal. So let me write here input. And we're using the same function. So if it was a different equation, we use a different function. If it was a different function, we have a different equation. So 2 squared is 4. 3 times 2 is 6. Minus 4. This is 6. 4 plus 6 is 10. Minus 4 is 6. And that's your output. And then it works the same if you just put anything you want in there. Let's say f of r. You could use a letter. Use anything you want, actually. X equals to R is the output. Excuse me, your input. So this would be R squared plus 3R minus 4. And because R is a variable, you can't really combine like terms. So that's your output. And it pretty much works for anything. And I'm not going to go too far here. But let's say you have a little stick figure guy. Not my best artwork. But this thing just becomes stick figure squared plus 3 stick figures, or 3 times a stick figure, minus 4. That would be your output. Where x equals stick figure would be your input. Oh, I'm sorry. That's what I was saying here. I just looked over here. I didn't see it wasn't on the screen here. But I just happen to just choose random letters like A, B, C, D, whatever letters I want. I happen to choose R. Plug in R everywhere I see X. I wanted a little stick figure just for whatever reason. This replaces the X. That will conclude 2.3. This will be a lesson from 2.1, 2.2, and 2.3.